Have you ever noticed how maybe your friend gets really excited about some new health hack and suddenly you want to try it, even if you're normally a bit skeptical?
Yeah, or the opposite, right? Someone tells you a horror story about a treatment.
Exactly. And you're immediately like, nope, not for me. It's pretty amazing how our perceptions, even for something as personal as pain, are so, well, fundamentally social.
Literally are.
So today we're taking a deep dive into the honestly surprising science of how simply watching other people can literally reshape our own experience of pain and pain relief too.
hmm
We're exploring how we can sort of learn pain or maybe learn pain relief just from others through this powerful process called observational learning.
That's the core idea.
Yeah, and our mission for this deep dive is to really unpack a, a very rigorous systematic review and meta-analysis. It was led by Stephanie Meeuwis and her team, published in the journal Pain back in 2023.
A top journal for this field.
Definitely. And they meticulously looked at 21 individual experiments, pulled data from 17 of them covering over 760 healthy people. The goal? To figure out how just watching someone else's experience can trigger pain relief. That's the placebo hypoalgesia bit.
Right.
Or actually increase pain and nocebo hyperalgesia just in the person watching.
Uh-huh.
So we're here to pull out the key insights, the kind of surprising facts from this research to help you understand this, well, powerful social influence on your own well-being. It often works below the radar, doesn't it?
It really does. And I think to properly get into these findings, it helps to quickly define what we mean by placebo and nocebo and how they tie into learning.
Good idea. Lay the groundwork.
Exactly. So placebo hypoalgesia, that's when you get genuine pain relief. But it's from something inactive, a placebo basically, because your mind expects it to help.
Okay, so it's not the sugar pill itself, it's the belief attached to it. And nocebo hyperalgesia is just the dark side of that.
Pretty much, yeah.
Yeah.
That's when the same inactive thing, or
Mhm.
maybe just a negative suggestion, leads to an actual increase in pain.
Mm-hmm.
Again, the intervention isn't causing it directly.
Yeah.
It's the negative expectations or associations firing up.
Right. And this isn't just about pills or creams, is it? These effects are tied into how we learn generally.
Absolutely. They're rooted in basic learning processes, like classical conditioning,
Mm.
Pavlov's dogs. Same idea. If an inactive cue, say a red light, is always paired with actual pain relief, eventually, just seeing the red light might start to trigger that relief response. You've learned the association.
Conditioned learning makes sense.
Yeah, and then there's operant conditioning.
Mm.
If you've used a certain technique before and it genuinely helped your pain, that positive experience reinforces your belief, making the placebo effect stronger next time.
Okay.
And don't forget verbal suggestions. Just being told, this is really effective, or conversely, this might have side effects, can have a huge impact on what you feel.
Right. So those are ways our own direct experiences or things we're told shape our pain. But this study is about something different, isn't it? What happens when you're just watching someone else?
Exactly. That's where observational learning, or AOL, comes in, and it's what this review focuses on. It's unique because it's indirect. You learn by observing a model, another person's experience, not through your own trial and error or direct instructions.
And the big takeaway from the meta-analysis, does this indirect observational stuff actually work?
Oh, definitely. The pooled data from those 17 experiments was quite clear. Observational learning is effective in modulating pain. It's not just a tiny effect. It's a measurable, significant influence.
Okay, let's get into those core findings then. What did they find about the impact on actual reported pain intensity? Like how much pain people said they felt?
So for pain intensity, they found what they called a small to medium effect. Numerically, the standardized mean difference, the SMD, was 0.44.
Okay, small to medium. What does that translate to, roughly?
It means watching someone else react, whether they seem to be getting relief or feeling more pain, does genuinely, measurably shift your own reported pain level. It's a real change, even if it's not, a massive one in every case.
Interesting. But what about our expectations of pain? Did watching others hit our expectations harder?
Much harder, actually, yeah. The effect of AOL on pain expectancy was rated as large. The SMD there was 1.11.
Wow. 1.011 compared to 0.44. That's a big difference.
It is. It really shows that what you expect to feel is profoundly shaped by observing others, much more so, it seems, than the immediate pain rating itself.
So what does that tell us? Why such a bigger impact on expectancy?
Well, it strongly suggests there's a really powerful cognitive, anticipatory part to this. Our brains are actively using the social information, what we see happening to someone else, to predict our own future feelings.
Like prepping ourselves based on their experience.
Exactly. Our expectations are highly sensitive to these social cues, and those expectations then likely feed back and influence the actual sensation, even if more subtly. The brain's trying to get ahead of the game.
That makes a lot of sense. Okay, so the study also looked into factors that might change how effective this observational learning is, right? Modulators.
Yes, they did.
Yeah.
And one really interesting finding was about how you observe the model, specifically comparing watching someone live in person versus watching them on a video.
Ah, okay. What difference did that make?
It was a bit complex. Observing someone in person seemed to produce a larger average effect on pain, potentially more powerful for placebo or nocebo.
Potentially.
Yeah, because while the average effect size was larger, 0.94, it actually wasn't statistically significant when pooled across studies. There was a lot more variability, more noise in the data with live models.
So maybe sometimes it's super effective live, other times less so, making the average less reliable.
That's likely it. In contrast, watching a videotaped model resulted in a smaller average effect size, 0.21. But this effect was statistically significant and more consistent across studies.
Hmm. So video might be less intense, but it's more reliably effective, or at least easier to measure reliably in studies.
Precisely. It suggests that while a live, in-person observation could be incredibly potent, it might also be harder to control or achieve consistent effects with. Video offers a more standardized, reproducible impact. That's important if you're thinking about clinical applications, like how to best convey information.
Yeah, definitely. Okay, what about us, the observers? Do our own traits matter, like empathy?
They do. The study found a significant correlation between the observer's level of empathic concern, basically, how much you genuinely feel for the person you're watching, and the strength of the observational learning effect.
So the more empathetic you are, the more likely you are to catch their pain or relief, so to speak.
Essentially, yes. The correlation coefficient was 0.14, which was statistically significant. It points to our social wiring. Our capacity for empathy makes us more receptive to learning from others' physical states.
That's fascinating. Now, what about something that didn't seem to matter much? I remember reading something about the type of placebo.
Ah, yes, that was also quite revealing. They looked at whether the type of placebo cue mattered. Did it need to look like medicine, have medical connotations like a cream or a pill, or could it be something abstract, like just colored lights or shapes on a screen associated with pain or relief?
Did the medical-looking stuff work better?
Surprisingly, no. The type of cue, medical versus abstract, did not significantly change how strong the observationally learned effect was.
Really? So just watching someone react to a flashing blue light, supposedly giving relief, worked as well as watching them react to a fake pain cream?
Broadly speaking, yes, in terms of the magnitude of the learned effect via observation. It reinforces this idea that placebo and nocebo are really flexible, context-driven phenomena. It's not about the specific object, it's about the information and expectation that gets attached to it, and that can be learned just as well socially with abstract cues as with medical ones.
That really broadens the scope of what we think of as a placebo trigger, doesn't it? It's less about the prop and more about the story told around it, especially when learned socially.
Exactly.
Okay, let's dig into a bit more nuance. The study tried to separate out the placebo effect, the pain relief learned through observation from the nocebo effect, the pain increase. What did they find there?
Right, they did try to tease that apart, and they found that, across the studies, the observationally learned placebo effect, pain reduction, seemed to be significant. The average effect size was 0.64.
Okay, so AWOL seems to work for inducing placebo relief. What about nocebo?
Well, that's where it got tricky. The average effect size for the observationally learned nocebo effect, pain increase, was much smaller, 0.15, and it was not statistically significant overall.
So it looks like maybe AOL is better at teaching relief than teaching pain.
That's the initial impression, but the authors themselves urged quite a bit of caution here.
Why the caution? What was the issue?
It comes down to methodology, specifically the lack of a true neutral baseline in many of the included studies. Often, experiments compared a high-pain cue condition, e.g., watch someone react badly to treatment X, directly against a low-pain cue condition. Watch someone react well to treatment Y.
Ah, so they weren't necessarily comparing either condition to a no observation or neutral observation control group.
Not always, or not consistently enough across the board. So if you only compare the high pain cue reaction to the low pain cue reaction, it's hard to say definitively whether the low cue reduced pain from some natural baseline, placebo, or the high cue increased pain from that baseline, nocebo, or maybe a bit of both.
Right, you don't know the starting point. You just know the difference between the two observed conditions.
Precisely. So while the data hints that OL placebo might be more robust than OL nocebo, we need future studies with really clear baseline or no observation control conditions to firmly establish the separate magnitudes of each effect induced purely by watching others.
Okay, that makes sense. Methodological details matter. Now, beyond just the raw pain intensity score, did observing others affect other aspects of the pain experience?
Oh, absolutely. It wasn't just about the pain number. The review highlighted effects on several other important outcomes. For example, pain-related fear or anxiety. Every single study that measured this 5 out of 5 found that OL changed people's fear or anxiety levels about the upcoming pain.
So watching someone else cope well or badly directly impacts how scared you feel.
Seems like it. And also pain unpleasantness, how bothersome or distressing the pain felt, separate from its sheer intensity. Half the studies looking at that found changes induced by OL.
So it hits the emotional quality of pain, too.
Yes. And it even showed up physiologically. Some studies found measurable differences in things like skin conductance, basically how much you're sweating, an indicator of arousal and heart rate based on what participants observed.
Wow.
And perhaps most intriguingly, brain imaging studies using EEG, MEG, fMRI, started to show how this happens in the brain. They found that OL-induced placebo effects were linked to specific neural pathways involving areas related to attention, like the prefrontal cortex, and areas involved in understanding others' perspectives, like the temporoparietal junction.
Incredible. So you can literally see the brain changing its activity patterns based on observing someone else's pain or relief experience?
That's what the initial neuroimaging work suggests, yeah.
Okay, let's connect all these dots. Why should you, listening right now, really care about this? What are the real-world takeaways, especially thinking about managing pain, maybe chronic pain?
I think the implications are actually pretty substantial. First, thinking positively, healthcare providers could potentially use this to maximize placebo effects by strategically and ethically, of course, sharing positive social information, highlighting success stories, maybe carefully selected accounts of other patients who benefited from a treatment. It could subtly boost a patient's own expectation of relief.
Using positive observation to enhance treatment. Makes sense.
And then there's the flip side, preventing nocebo harm. Understanding how seeing negative stuff can increase pain is just critical today. Think about the internet, social media.
Oh, yeah. Health forums, Facebook groups.
Exactly. You're constantly exposed to verbal modeling, written accounts of other people's negative experiences with treatments, side effects, terrible symptoms. Reading all that, especially before you even start a treatment, could unintentionally ramp up your own negative expectations and even symptoms.
Setting you up for a nocebo effect before you even take the first dose.
It's a real risk. Now, it's important to remember most studies here want healthy young people. We need more research in actual clinical populations.
Right. Does it work the same way for people already dealing with chronic pain?
Well, there was one study mentioned that looked at chronic low back pain patients. It found that observing others having beneficial treatment outcomes didn't significantly reduce the observer's pain intensity, but it did reduce their perceived disability.
So maybe not the raw pain score, but how much the pain interferes with their life, their function.
Exactly, which for chronic pain is often a huge part of the problem. So even if AOL doesn't erase the sensation, influencing function and perceived ability is still a really valuable outcome.
Definitely. So lots more to explore there at clinical settings.
For sure. Future research is looking into all sorts of things like, does the model's gender or social status matter? Does your empathy in that specific moment, your state empathy, play a bigger role than your general disposition? Lots of fine-tuning needed to really understand how to best use AOL for health.
It really underscores how well interconnected we are. Our minds, our bodies, they're not isolated. They're constantly interacting with our social world. This deep dive shows just how much observing others shapes our reality, right down to physical sensations like pain.
It's a profound link.
Yeah, it really makes you think, doesn't it? Given how powerfully our observations shape pain and expectations, you have to wonder, how is the information you consume every day, maybe unconsciously scrolling through reviews or just casual chats with friends, how is that subtly nudging your own physical and emotional state? Maybe the question for you to reflect on is, what steps could you take to be a more mindful observer? Or perhaps, knowing this, how could you be a more positive model for the people around you? It's a reminder of those subtle, powerful ways we constantly learn from each other. So keep observing, keep questioning, and keep learning.